was it like really long and then you went
It
short?
was like down to here, and
Okay.
then it was cut to here. I do kind of.
You didn't have like a 2020 panic and like freak out and then you cut it to like in the pixie
No.
cut.
No, but my hairdresser won't cut my hair short anymore. Like, cause she's.
Poor Lacey.
How was it? I donated all of it. It went to a good cause, but like,
What'd you donate
I don't know,
to?
a non-profit.
I grew my hair out in college, down to here, and I donated to Wigs for Kids.
My mom was retarded. I was
That's weird to think about it. Being 14 and 12. Yeah, because I was like 13.
Okay, all right. We are going to draw some slope fields today. That's not that bad. It's mostly just plug and chug, and then we got to graph it.
I'm not very good at graphs.
You don't have to do it on your AP exam, but it will help you when we do this part later on. Okay, let's just do this the easy part. The easy part we just plug and chug. Okay. They give you a differential equation, dy over dx equals 3x minus 2. Let's just plug and chug. Pick a number.
One.
All right, you pick one. Correct. Let's do that. Let's pick one. I'm gonna start from left to right because that's what's on the table. We got -2, -2, -1, 0, 1, 2. I just picked these dots right here. Okay. Plug it in. Well, what's -2 times 3? -6, -6 minus 2. -8. Oh. -1 times 3. -3. -3 minus 2 is -5. 0 times 3 is 0. Minus 2 is -2. 3 minus 2 is 1. 6 minus 2 is not too bad. Let's graph this, and this is where things are going to feel weird. Because we're not going to connect the lines here. We're going to draw instantaneously what is the velocity, or sorry, the rate at that moment. So at -2, when we plugged in -2 for x, right here. What was my slope? What's my rate? -8. How do we draw a slope of -8? It'd be pretty steep negative line. See that right? 5 is negative slope. Right? When we plugged in -1, what was my slope? Not as steep, but still negative. So I'll do like that. What was it at 0? Not as steep. At 1, now we're positive. And then at 2, we're even more positive. There we go. We just drew the first one. I'm going to ask a question. It's not a trick question. It just feels like a trick question. Were there any y's involved here? No. So does that change at all with my slopes in the y direction? No. So these slopes are all the same. See that? Those are all -8. What color code mine to? Those are all -5. The last one got a little wonky on me. Another color. This one is going to be -2 all the way down. +1, +1, +1. Last one's going to be +4. There you go. We just rough-handed a slope field. Cool. Like I told you, it's not too crazy. Feels ugly because it kind of is ugly. Okay. Now, so this is the slope field produced from this differential equation. My question then would be is, can we also write the equation that's going to be there? And that's what we did yesterday. We did this yesterday. Well, how do I get that dx to the other side? Multiply by dx, right? So we get dy equals 3x minus 2 dx. How do we get rid of the dy and the dx? We do the integral, we do the antiderivative. So we do the antiderivative to both sides. So we should get y equals, what's the antiderivative of 3x? Add ons is 2, 3 over 2x minus 2x. I made 2 mistakes. Should be x squared and
Plus C.
plus c. Goodness.
And that is the
This is the equation. The original equation. This is a graph showing the derivative, or the, what's the word leaving me? Not multivariate. Differential equation. Now that one is decently not too complicated because there was no y's in here. There's no y variables. Really making it a true differential equation. Sound okay? Full check, right? All right. This one's got a lot of numbers in there. I'm just going to give them to you for the sake of time. But the first thing I do want to do is I do want to rearrange this slope, or sorry, this rate right here, dy dx, by itself. How would you want to do that? Well, I'll get to the other side first. So I'll do 2x equals y dy dx. Right? I just add it to the other side. And I'm going to divide by y. So what I'll get then is dy over dx equals 2x over y. What's the difference between this example and the last example? There's a y variable. Okay. This is something we're going to hit on a little bit later, but do you see how this one had an x variable? My slopes were changing as I went from left to right in the x direction. Follow me there? Since this has got an x and a y, it's going to change both directions. It's going to change the x and y. To prevent from us doing a crazy amount of math, -2, you pick any point, and you create this whole table field. Now the reason I don't ever think you're going to be drawing one of these from scratch, and I could be wrong, I'll eat my words if I am. -2, 1, 1, 1, 1, 0, D&E doesn't exist because you can't divide by 0, 1, -1, and -2. All I did was just pick some points on here, so like -2, picking this point right here. Well, +2, -2, +2, that point right there. What's the slope of that point? -2, so it looks something like that. Okay. For the sake of time, I'm just going to go ahead and just draw this. That one's a little steeper, less steep, 0, steep, more steep, less steep, 0. There's not really any color coding because I color coded these ones because all these slopes were the same.
Okay.
None of these slopes have a pattern. Well, I guess the pattern would be that one, oh, and that one would be the same. What do you mean?
I like the annotating for the graph.
So
So like the -2 is the position.
I'll highlight. I'm not going to highlight. That one is that one. Just gonna start picking random colors now. That was too much yellow. One. Ooh, doggy. -1. There you go.
Just reflect them.
Yeah. We could make a whole table that does all of them. But after that, you have enough information to start repeating your pattern. Okay.
Yes.
Feel good here? Just plug and chug and graphing the slopes. Okay, now can I also write my original function from here? Well, sure. All I have to do is get y dy on one side and x dx on the other side. Can I do this and you guys not go crazy on me? Can we cross multiply? Since that's a ratio. So we got. I guess you guys have never gone crazy on me. It's a little steep. Y dy equals 2x dx. Now we do the antiderivative of the integral of both sides. Ooh, what does y turn into? Be y squared, right? Y squared divided by 2? Equals x squared, right? C plus c. And then we get y squared by itself then at that point, so it'd be y equals 2x squared plus c2. We haven't done that. It's okay. We've talked about that. What's c2 mean?
Divided by 2.
It looks as if you're doing some sort of math operation here. Absolutely. All we're denoting is that this c is different than that c. Because what did I do to get rid of this 1/2? Multiply everything by 2. So rather than just putting 2c, we actually put it's a different c. Because sometimes you multiply by 2, the number changes based on what it is. Is y by itself? No. So square root of 2. Sorry. All right, that's it. Now we're done. You can circle that one. plus or minus, since it is a square root. Alright, those are the only two we're drawing from hand. I lied. I got one more we're drawing. Yeah. This third example, is just a more complicated version of what we just did. It's just turn up the heat just a little bit. So since it turned up the heat a little bit, it actually broke down all the steps for you, and so this is a similar approach, but we're fully breaking the problem down. So let's plug in. They already gave you your dy dx, your differential equation already. You got it by itself, so I just want you to plug in the points. Plug in 1, 1, 1. Well, what's negative 1 divided by 1? Well, it's negative of negative 1 divided by 1. All right, that was unfairly complicated. Negative 1. So, just to put a quick little graph over here. At 1, 1, the slope's negative. At negative 1, 1, slope's positive. So what quadrants are we positive? Would you have a positive slope in? 2 and 4, absolutely. So Q2 and Q4. You want to do a quick big brain? What shape does it look like we're going to be drawing eventually? Circle. We're close to a diamond, but the slopes are always changing. We'll get there. It does look like a diamond though, but we're not going to play connect the dots. Negative n quadrants 1 and 3. Gotcha. Can you divide by 0? No. So all the ones with a 0 on it for the y is going to be, doesn't exist. Right. At what point does your slope not exist? You got positive slope, you got negative slope, you got 0 slope. Slope doesn't exist when you have a vertical line, right? Slope is undefined on a vertical line. And the slope is 0 on a horizontal line. Rather than beating this problem to death, I think we have enough pieces of information to graph our grid. I'm going to zoom in nice and close. We know what we just did is you have a horizontal line here. That's just what we did earlier. So it does not exist here, so we can't draw the slopes here. Don't do this. Can't do it. Because those are undefined slopes. You can't draw undefined slopes on a vector field. So don't draw those. We can graph the other ones we do have. I'm just going to plug and chug for us, that way we're not wasting tons of class time on this. are absolutely welcome to beat yourself silly trying to draw all these or calculate all these vector fields, but it's just a lot of algebra and I don't want to waste the best time on algebra. Depending upon, I don't know if this can work too much, on how effective your middle school science teacher was. You talk about something in middle school science that looks super similar to what we're drawing. Does anybody's brain happen to go to what you might have learned in middle school?
All I remember from middle school is classrooms.
Did you guys ever deal with magnets?
Oh my god.
Magnetic fields. Did you guys ever see like the magnetic field of Earth and like things like that? Or see like a bar magnet? Now I'm just gonna tweak magnetic fields, and I'm gonna put magnetic slope fields. Put the word slope in there. I thought it was gonna give me it. It's not gonna be. Oh, there it is. There's a three-dimensional slope field. Yeah, it's more Calc 3. But there is a slope field of a magnetic loop, so coils and things like that. So slope fields do have a point of purpose. Usually in slope fields, you also tie a value like force, since force is a vector field. So slope fields, when you apply some numbers to them, become vector fields. But in any case. Okay, let's draw. It says for one that passes through the point 2, 0. So we're going to start at 2, 0. I'm going to do it in red. Let's play follow the curves. Hey, look at that. Goes all the way to 2. Goes all the way to 2. Goes all the way to 2. Hey, look at that. It's a circle. Did you want? You can circle that answer. Okay. See if I know the equation of a circle. That's the circumference of a circle, baby. The equation, the actual functional equation of a circle. Good. Nailed it. What is my radius for the circle? 2. I think we can say y squared equals 4. Because 2 squared is 4. Minus x squared. There's our equation. There you go. And we're officially halfway down the notes.
How do we know what numbers?
Well, if I'm looking here at my circle that we just drew, that radius, I'll do it in blue. That radius is 2 units big. So I did 2 squared. 4. If we did another function, so like if we did another function, I'll do it in y and I'll do one. This function would be following that slope field, but then we would get a different function. It would be y equals the square root of 9 minus x squared.
Oh, never mind. I still need to
Yeah. What is before that solution curve is? But that was a very valid question. Extremely valid. Can I just say something over here?
Would it be plus or minus the square root? Y equals plus
Yes,
minus.
yes. I think, and I could be wrong on this, because That part is assumed unless it's pertinent to the question. But the reason I do throw that in there is because if we graphed this on our graphing calculator, it would actually only graph the top half. What? I haven't found one. I'll show you how I've done it. I gotta go back. Do you guys do stuff with polar stuff in pre-calc?
I think we talked about it.
We're just doing it, and I just don't remember helping you guys last year at all with it. And so I was like, no, you guys can do it. So if I go on my calculator and do square root, nope, try again. Square root, chill. Square root of 4 minus x squared. And I hit the graph button. It only does the top half of the circle. So I would have to come in here and manually put in also graph negative square root 4 minus x squared. And it'll graph both halves of that circle for me at that point. Okay, let's put our thinking caps on. And let's identify some slope fields. Okay. We're going to hit what G and H are talking about on that last page. So on this last page, we're going to talk about like hints on how to look at slope fields. But let's look at this. First step, when identifying a slope field, I would look at what are the ones that immediately stand out to you that look totally different from the rest of them. D and E. Why do D and E look different?
They're not.
No, it doesn't exist there. So I would look at which of my functions given would have a something that causes something to not exist. Well, I would just do ding, ding, ding. That's one of them, because you can't have the square root of a negative number, right? What's another one? 5, absolutely, because you can't have a natural log of a negative number. Cool. So looking at 1 and 5 right now, 1 and 5 are D and E. What's the only variable in number 1? X. So we got no Y. So this one should have a change of slopes in X direction only, right? And number 5 is going to have change in Y. So D is 1. Absolutely. Because if I'm looking at the slopes here, those slopes change as you go in the X direction. And E by process of elimination, right? But just to verify, do your slopes change as you go in the Y direction? They don't?
Oh yeah, they do because there's none at the bottom. Yeah. They do not. They change.
Well, even right here, right? It's negative 0 and then it's positive, right?
I see it now. I messed it up. I mixed them up.
So that's E. It's a weird E. Let's try that again. All right. Let's break it down from here. I'm gonna zoom out just to here. We're done with it. Let's now look at which one of these change in the X direction only. We got that one, right? So I'm going to label as X. This one is what? XY. So that one's got both. This one's X. What's 6 going to be?
Y.
Just Y. 7 is X and Y. 8 is also X and Y. Using process elimination will be my next easy one to tackle.
Y.
The Y one, because the Y one's by itself, right? So I'm going to do that. Which of my remainings here have the variables only change in the x and y direction. So here's what I do. I look at this picture, I look at the slopes. Hey, those slopes are changing in the x direction. So this one's an x. Are they changing in the y direction? No. So that one's x only. What about B?
X and Y.
X and Y? Looks good. So X and Y. C? Just Y, right? C is 6 by process elimination. We already figured out C is 6. F looks funky. That's X and Y, right?
Yeah.
What about G?
Just X. Or just
That looks like X and Y.
oh, yeah. H is just X.
H is just X, yes.
Okay, that I was on the wrong one.
Cool. So now we know 2 and 4 have to be which ones?
They have to be A and H.
A and H, right? Now, let's look at these real quick. Let's put our big thinking cap on. Ooh, how do we know that? You see the waves? Look at that. F would be natural log. I can't remember off the top of my head. We're gonna get that later. No. Should be the natural log. Wait, say it again. What's the question?
Would F be natural log? 'Cause it's got I'm trying to make myself do this.
No, we got some wavies in there.
Uh,
So let's finish up with the y's first. So what do we find out with our study x? So H was a slope field that looks like it's trig in nature and it only deals with x. That's going to be number 4, right? See that? So by process of elimination, A is going to be 2. So I'm going to erase. So we got 3 now that are left. That are, so we got A, F, and G.
Okay, BFG.
BFG? BFG, yes. B, F, and G. Ooh. 2 of them are trig functions, one of them is not. Which of our 3 left over does not look like a trig function?
But
Buh. B is in buh. Oh, I'm about to put that in the wrong spot too. Is everybody good on that one? They see that? B's the only one that doesn't have wavies in it. F's got some wavies in it, so it's probably trig related. G's got some wavies in it, so it's probably trig related. Now, what would I do for this last one? How do we get trig functions to know which one's which?
I think
G is sine? What makes you say that?
because it's a wavy in the Y direction.
So,
Like going up. It looks weird. And F is like it looks way more, F looks like almost like a pattern. Yeah.
there is definitely a pattern there, absolutely. Do you see how that pattern changes in the X and Y?
Yes. Diagonal.
It's a diagonal, right? This one, the trig function only affects the Y direction. This one, the trig function affects the X and Y direction,
Makes it diagonal.
which makes it diagonal.
See. What if it was was that, but it was like x and negative y.
X and negative y, I'd probably just flip it. And so that by process elimination, that leaves G. Now, there's also another way to do it.
Let's just write them out every single time.
There's also another way to do it. Here's what I do. I look at what is the slope at 0, 0. The slope here is 0, right? Slope here is positive something. So if we look at cosine sine, there's your sine function, right? For a sine function, what's your slope at the very beginning? Your instantaneous slope. That's positive, right? Did I do that right? Am I looking right? Nah, I'll backtrack that. I think it's going to go down a rabbit hole. That's not going to be helpful. Cool. I erased my B. I don't know how I did that. So let's write our steps on how we did our strategies. What's the first thing we looked for?
Change that.
We did something before that, right? Does not exist. So strategies is the first thing I would look for is see where your slope does not exist. So dy over dx does not exist. That's the first thing I would do. And that was looking at, there's a couple of test cases. One of them could be your radicals, your square roots, right?
I'm so hungry.
What's another one? Divide by 0, natural log of some number can equal 0, right? Divide by 0. Okay, so if it gives you some instance where the slope does not exist, that's the first thing I would do. Look at that. Then the next thing I had, you see where it changes in x and y only, right? Next thing we looked at was see where the slope changes, your rate changes, x and y. That's the next thing we did. And I technically combined two of them together, so we're only going to do 4. So what's the last thing you looked for? What's the trig functions, right? Check for trig. And trig makes wavy slip fields. Is that how you spell wavy?
Looks wrong.
It does look wrong. Also, when I write on the board, I have to write kind of big. So it's like, I'm like looking at wavy super big, and like, that doesn't look.
If you look at any word long enough, it doesn't look like it should be spelled like that.
Sometimes I get that.
Like the word couch, that's wrong. That's right.
How do you spell it is?
Yeah. Wavy.
If you spell it W-A-V-E-Y, that is a snow goose from Canada. That's called a wavy.
I want one.
Okay. So here's what I do expect you to do. Okay. If it is, let me go back here. Oh, I don't want to go through. I want to do that. I want to go back here. All right. If it is an FRQ question with a slope field, I imagine it's going to be more of a straightforward one like this first one. That's a big if. If it's not, and it's like a multiple choice question, it's going to look very similar to this. They give you an equation, they give you a differential, match the graph. Okay? You're never expected to draw, and I would argue this till I'm purple in the face. You would never be able to expect to draw this from scratch. Okay? That's a lot of calculations. You should be able to identify it. Okay. Do we want to do this last one? Let's do it. Yeah, let's do it. It's just good practice. It's nothing crazy new. We're just going to find a C at some point.
It was called walking into that.
We got a differential equation. We even give a point for us to look for that equation. So the first thing we're going to do is get dx over to the other side. So it's going to be dy equals 1 over x plus 2 dx. What's the next step? Antiderivative. So that's going to be y equals what? What's the antiderivative of 1 over x? Natural log. Natural log of the argument. X plus 2 plus c, right? Hey, they gave us a point to look for. So can we find c now? Sure. Let's plug in the point. What point did they give us? 0, 1. 1 equals natural log. 0 plus 2 is just 2 plus c. What does c equal? Ready to run.
Absolute value.
Yes, why would we do absolute value? Because it has to be positive. You can't take a natural log of a negative number. So, yes, you don't have to simplify more than this. But we got to find the solution of the differential equation. We have C now, right? Yeah, put it back in, and then we can circle it. So our generic solution, or sorry, specific solution is natural log x plus 2 plus c, which is 1 minus natural log of 2. Yep. I'm going to draw 2 more lines and we're done for today. Here's what you should be able to do. Put big brain on real quick. Do we see how the slopes are becoming more and more vertical right here at -2? So what do you think we have at -2? What's that called? Asymptote. We got a vertical asymptote at -2. Oh, a little wavy there. So what's the point we did? We did 0, 1. So can I draw my function from using the slope field information and that vertical asymptote? Well, sure. It's going to look something like this.
I'm not gonna lie, I would never see it without that. I would just,
But do you connect the dots now?
yeah. But I
Cool. All right. That's it. I'm done.